Now I have come to hierarchical or nested ANOVA. And in this example, we're interested in the tail length of rats. A researcher has measured the tail length of rats on 8 different islands in 4 lakes. And with this as setup, he can ask several questions. For example, are the tail lengths the same between islands? Or are the tail lengths the same in different lakes? How do we actually formulate a good hypothesis about the tail lengths? Let's look at how we could put up ANOVA tables, and for now we're just going to focus on the degrees of freedom to see how they fit together. So if we start to look at the question, are the tail lengths the same on different islands? We have a total number of degrees of freedom, that is 79. Our total sample is 8 times 10, which is 80, minus 1 is 79. And we had 8 islands. That gives us 7 degrees of freedom. And the degrees of freedom have to sum up to the total. And that means that our within component will have 72 degrees of freedom. We could also look at the question if tail lengths are the same between lakes. Again, the total degrees of freedom is 79. And we only have 4 lakes, so between the lakes, the degrees of freedom is 3. And the degrees of freedom have to sum up, so the within component here has 76 degrees of freedom. But what we're really interested in is perhaps, is there an overall effect on lakes on the tail length? And is there an effect of islands within the lakes? And to test this, we need a slightly different setup, which we're going to do now. Again, we're going to look at the degrees of freedom. The total was 79. Between lakes, it was 3. And within lakes, it was 76. But this within component can also be divided into 2 components. That is, between islands within lakes and within islands within lakes. And we want to divide the within lakes component degrees of freedom. And by doing that, we will also, of course, divide the sum of squares, because they also sum up in an ANOVA table. So the sum of these degrees of freedoms should be 76. But what are they? First, look at the between islands within lakes. In one lake, we have 2 islands. That is 1 degree of freedom. And we have 4 lakes. So that is 1 times 4, which gives us 4 degrees of freedom between islands within lakes. And as I said, the degrees of freedom have to sum up to 76. So within islands within lakes has 72 degrees of freedom. You could also get to this number 72 by seeing that you have 10 samples from each island. That is 9 degrees of freedom for each island. 8 islands gives 9 times 8 degrees of freedom, and 9 times 8 is 72. This within component is sometimes also called error. That is our random variation. Our variation that is not explained by our variables lakes and islands. And this within component you rarely have to write out, but it's good to do it here just for exercise. And the reason why we do this exercise with degrees of freedom is that it's actually not particularly difficult. And if you know what the degrees of freedom are, you can easily check that the statistics software you're using actually does what you think it does. Also, if you have the degrees of freedom and some variance, that is, mean square, for example the total variance, you can get the sum of squares by multiplying the mean square with the degrees of freedom. And the mean square within islands, within lakes, that is the same as the pooled variance. So if you have some sum of squares, by subtracting, you can get the others. Now the question is, how would we do our statistical test here? If we want to know if there is a difference between islands within the lakes, we would divide the mean square for islands with the mean square for within islands. And you divide the mean squares to get an F value to do the statistical test. And if we want to test if there's a difference between lakes, we will divide the mean square between lakes with the mean square for between islands within lakes. And you see here that we have an hierarchical setup. One variable is nested within the other, and that is, we have an hierarchical or nested ANOVA.